In this video, we will discuss about subtopic 5.3, which is about solid. At the end of this lesson, students should be able to, number 1, explain the fixed shape of a solid, and number 2, student must be able to apply the kinetic concept to explain the following process, which is number 1, freezing, also known as solidification, number 2, melting or fusion, number 3, sublimation, and number 4 is deposition process.
Which of these materials can be described as a solid? Rock, gold bar, a china teacup, a pizza. They are in fact all solids.
Fixed shape of a solid. Do you know why solid has a fixed shape? Why? So, look at this diagram. Okay, this diagram shows the arrangement of the particles in a solid. So, we can see that the particles in a solid are arranged closely together in a rigid arrangement. Due to this arrangement, intermolecular force exists between the particles is strong. That's why solid has a definite shape, size, and volume. Compressibility of a solid is very low because the space between the particles is small. Ability to flow, none. Density of solid is high, and the particles in a solid only can vibrate and rotate about fixed position due to strong intermolecular force in solid. Now, let's talk about process change or phase change. What is meant by process change? It is process by which we can change one state of matter to one another. So material can exist in three main types state of matter, which is number 1 is liquid, number 2 solid, and number 3 is gas. So the process change that transform from solid to liquid known as melting, and the process from liquid transform to solid known as freezing. Sublimation is the process that involves transformation from solid phase to gas phase and from the gas to solid known as deposition process. The process that involves the transformation liquid to the gas known as vaporization and from gas to liquid known as condensation. In this subtopic, we only will discuss about 4 process change that involve solid state, which is number 1, melting, freezing, sublimation, and the other one is deposition. Now, we will discuss about freezing process. Freezing process, also known as solidification process. In this process, matter makes transition from liquid to solid. In terms of kinetic molecular theory, when the temperature of liquid is lowered, the average kinetic energy of liquid molecule decreases. So, the liquid molecule will vibrate at slower rate and moves slowly. When the molecule collide, attractive force of the molecule can now overcome of those molecules with low kinetic energy and hold them in a fixed and orderly arrangement, thus liquid changing into solid. Melting process. Melting process, also known as fusion process. This process involves transformation from solid state to liquid state. In terms of kinetic molecular theory, when the temperature of solid increases, the average kinetic energy of solid molecule increases. So, the solid molecules vibrate at higher rate and move faster. When the molecule have sufficient energy to overcome the intermolecular force that bind them, they are free to move, thus solid changing into liquid. Definition of melting point. Melting point is the point at which temperature solid substance turns into a liquid. At this point, solid and liquid phases are in equilibrium. Definition of normal melting point. Normal melting point is the point at temperature equal to 1 atm, which is a solid substance turned into a liquid. At this point, solid and liquid phase are in equilibrium. Sublimation process. Sublimation process involves transition from solid to gas. In terms of kinetic molecular theory, when the temperature of solid increases, the average kinetic energy of solid molecule increases. When the solid molecule have enough energy to overcome the intermolecular force, it changing rapidly into gaseous state. So, molecule able to move freely. So, solid turn into vapor directly. Example of sublimation process is from carbon dioxide solid to carbon dioxide gas. Get your popcorn ready and let's enjoy this video.
Why do mothballs disappear over time? Wow, you have a nice collection of clothes. But have you kept mothballs to protect them?
Yeah. I kept them a few months back below these clothes. Hey, where did the mothballs go? I placed them right here. Did you steal them?
No, I haven't stolen anything. Mothballs disappear over time. Do you know why? It is because of a process called sublimation. During sublimation, a solid on heating converts directly into vapor without passing through the intermediate liquid state.
Don't lie. How is that even possible? See, I also hit a burger here many days ago. It did not disappear.
Ooh, gross. Just throw that burger in the dustbin. Not all substances sublimate. Mothballs are made up of naphthalene. Naphthalene has very weak intermolecular forces. Because of these weak forces, the mothball, which is made up of naphthalene sublimates, that is, it changes its state from solid to vapor. Now, this vapor is either absorbed by the fabric or it escapes into the atmosphere, causing the mothballs to disappear over time.
Deposition process. This process involves transformation from gas state to solid state. In terms of kinetic molecular theory, when the temperature lowered, the vapor molecules move slowly and become closer to each other. When the molecules collide, the strong intermolecular force enough to hold the molecule firmly or in definite shape. Thus, vapor turns to solid directly. For example, iodine gas changed to iodine solid. For more information, keep watching this video until the end.
This is elemental iodine. It's a dark, black bluish solid at room temperature. Iodine is the heaviest of the stable halogens. When we heat up the iodine, it's going to turn directly from a solid into a gas. The iodine vapor has a beautiful purplish color. This process is called sublimation, turning directly from a solid to a gas. Now we place a cold flask over top of the vapor. The warm vapor will cool off on the cold glass, and the gas will turn directly into a solid. This process is called deposition. In this case, we're seeing the deposition of iodine onto the cold glass surface, where we would say that iodine is depositing onto the cold glass. We can't do this experiment in our science classroom because the iodine gas would be harmful to us.